Hey there, it's Horner, and I just want to go through this worksheet, kind of show you how it works. There is a block, and the block is sitting on top of a frictionless surface. So when you pull the block back, it compresses the spring, and then when you let go, the spring pushes it really fast from A to B. So at A, we don't have any speed at all, so your velocity here is equal to 0. At B, as we move to the right, your velocity now is a max, and it's positive. And when we get over to C, our velocity is 0 again. Now we're going to go in the other direction. So now we're going to say these are velocity right, and then here we have a velocity in the left direction. It's 0. It's going to move this way. It will have velocity max again, but this velocity max should be negative. And then as it moves over, we're going to say the velocity on the left, going left here, is also 0. So 0 on this side, 0 on this side, a negative Vmax here, and a positive Vmax when you're going to the right. So that's essentially what's happening. Let's go through and let's kind of graph what happens. We have a position versus time graph, and on this position versus time graph, we're going to start at B. So you'll see B is the starting position, and we're going to move to C. Notice that we're moving right, so right is positive, so we're going to go up and we're going to go positive. Now notice that my curve here is always going to make a hill. So this looks like a hill. We went from B, and we went right to C, and then we went back left again, and we went back to B. Now we're going to go to A, and if we go to A, notice that we've got to start by going from B, we're going to travel left, and then we're going to go back to B again, and then this whole cycle just continues to repeat. The big deal here is we always want to have nice smooth mountains and nice smooth valleys. You don't want to have any peaks, so you don't want to see anything like this. This would be incorrect. We want to make sine curves. We don't want to make a bunch of peaks. So we're going to continue just making these curves as we go through. So this one comes back up, goes here, comes back down here, and then back up again. So that's our position versus time. The next one that we probably need to look at, we can look at velocity, acceleration, or force. Any of those will do. If we go to force, notice that going from B to C, if we start at B and we go towards C, our force is now pointing in the left direction as we go from B to C. Why is that? It's because when the block gets over to C, the spring is pulling it in this direction. So the force from here to here has got to be to the left, and that's because the spring is pulling it in that direction. So from B to C, we're going to have more and more force in the negative direction, and then when it comes back, it's going to go this way. And then we just go ahead and can keep going with our curve here all the way over, just like we did with the position versus time. So we just want to make sure we make nice smooth valleys and nice smooth hills. And so we'll do valley again, and then we'll do a hill again. So this is exactly the opposite, you'll see, of the position versus time. Our acceleration, remember, F is equal to mass times acceleration. And so when this thing accelerates, it has more force. When it has a negative acceleration, it has more force in the negative direction. Because of that, these two graphs should be exactly the same. So this one's going to go down, this one's going to go up, come back down, and then the cycle will just continue as you go through. And if you think about it, it should make sense, because as you go from A to B, so as we go from A to B, so here's an A, we're going from A to B, our acceleration will change. It will decrease as we go through here, and then it will from B to C, so here's B to C, it gets very big in the negative. And then our acceleration is going to go pick up again and then get small, and then pick up and then get small. So you'll see that in the graph as it goes through. The very last thing we have to look at is velocity. We want to know what the velocity is. Remember, we said that going to the right, our velocity maximum is positive. So at B, our velocity maximum is positive, and then at C, our velocity is 0. So we've got to make a curve that looks like this. And then when we go from C back to B again, we pick up speed, but this time in the negative direction, and then we lose speed in the negative, and then pick it up in the positive, lose it in the positive, and then we just keep going as we go through. So this is the graph for velocity versus time, and that's what it looks like. So you'll notice that this one's a little different. These are all what we call in phase. Some of them are flipped upside down, so they're opposites. This one is out of phase. It's because it doesn't start with a peak. It starts with a peak, and then these do not start with a peak. They start with a node. And then here we've got a crest. Here we've got a peak and a peak, but this one now is at a node. So you'll see that they're offset by a little bit. But that's what it should look like, and this is where we're going to start and kind of build from there on.